Welcome. In 9.2 we're talking about ellipses. This might be your first look at these, but we're going to go ahead and go through this. You can come back to these and refer to it. But this is the standard equation of an ellipse. Looks like this, where HK is the center and A and B, if you could imagine for a moment that these were both A, because these are different values here, and I would multiply both sides by a squared, I would get x minus h squared plus y minus k squared equals just a squared. And if we had that, we'd recognize pretty quickly, hey, this is just in the form of a circle. So this is a circle. It's just kind of a skewed circle because in this case, both of these relate to a squared, but over here they both relate, our x's and our y's relate to different values. So the major axis would be horizontal, and you note A is always bigger than B, and they're both positive. And so our major axis is our long axis. We would say that this is a short and wide ellipse. This is a tall and skinny ellipse. The A value, the bigger value, is under Y. And I would normally write this first. But let's go back to the definition of an ellipse. Definition of an ellipse says an ellipse is a set of all points x, y in a plane, the sum of whose distances from two distinct points, called the foci, is constant. And this whole constant thing, we're going to talk about that in a little bit. But basically, if we have an ellipse around our two fixed points, let's say they're here and here, here's the definition. Here's a picture of the definition of an ellipse. If I call this D1 and this D2, so the sum of distance 1 and distance 2, that's what they're talking about, the sum of the distances. And I'm going to put this one in here. Let's call this D3, D4 is constant. So D1 plus D2 equals D3 plus D4 equals D5 plus D6 equals D7 plus D8 equals D8 plus D9, or D9 plus D10. Doesn't matter. Those are constant, but it's not just any old constant, as we're going to see in just a bit. And that's an important part of the whole construction of ellipses. It's not just any old constant. Okay. We have a thing called eccentricity of an ellipse, which we're going to talk about a little bit later. And we have a Pythagorean relationship between A, B, and C is the distance to the focus, to the foci from the center of the graph. I'm going to lay all that out for you down here, but you're going to see I will commonly write this as A squared equals B squared plus C squared. In the Pythagorean relationship, I like to talk about the longest part first. And they say, well, when the center is 0, 0, we're just x squared and plain old y squared rather than x minus h and y minus k. From what we know about circles, that's consistent for us. So let's go ahead and lay this out. Let's say the foci, and we'll talk more about the foci and how they develop the width of an ellipse. But let's say the foci are located here. This distance is referred to as C. This would be like focus 1, focus 2. And you'll hear me say a number of times that you can't spell focus without C. The distance from the center to the focus is C. Now, half the major axis is A, and half of the minor axis is B. But this A repeats itself. This A occurs right here as well, and there's our Pythagorean relationship, A squared equals B squared plus C squared, which is a little bit confusing perhaps if you don't see the picture, because we're used to, from geometry days, C was always the hypotenuse. Well, it's not here in ellipses. Okay, now if we go back to the sum, back to thinking about this, the distance, if I take this distance plus this distance, this clearly would be A, we get 2A. That means that this distance plus this distance is 2A, and this distance plus this distance is 2A. So this constant, it's not an arbitrary constant, it's 2A, or it is the length of the major axis. Okay, let's take a look down here. I'm going to, and it's not really right, I guess, to do this, I would refer to this as an x squared ellipse, even though they're all x squared and y squared. And this is a y squared. This is x dominant, I probably should say. So this is x squared on 9. Now, if you notice, that means A is 3 here and B is 2 here, from what we were talking about up above. And from the center, the x distance is 1, 2, 3. So the major axis, half the major axis, 1, 2, 3. 1, 2, 3. In a y direction, we move 2. Up 2, down 2. Likewise, center 0, 0. Up 3, down 3. That's our y right there, 3 squared. Up 3, down 3. And right 3 left, or right 2, left 2. And here we've got a center of 2, negative 1, and that might be enough for us to know what's going on. 2, negative 1, this is C. Guess I can come up and label these. This was B, this was A. But it's also worth noting that the x distance from the center appears to be 1, 2 to the right, 2 to the left. The y appears to be up 3, down 3. And this, of course, must be D, but let's take a look. Center, negative 2, negative 2. That seems like it's right on the money. We go right, it appears 3. Left, it appears 3. We go up 2, down 2. All right, well, I think graphing these things, if we can get the equations in this form, should be pretty easy. Here I would just go to the right 2, down 1. And then from that point, I'd go right 2, left 2, up 3, down 3. And just try to fit in an ellipse. All right, we'll zoom in here a little bit. And here we are to find the standard form of the equation of the ellipse with the given characteristics and the center at the origin. And this is wider 4 than it is tall, 3 halves and 3 halves. 6 halves are 3 tall, 4 wide. Therefore, I would refer to this as an x squared or an x dominant, and it's centered at 0, 0, so this is x squared on a squared, a not being the whole axis, but whole major axis, but half the axis, so that's on 2 squared, plus y minus 0 squared on 3 halves squared equals 1. X squared on 4 plus y squared on 9 fourths. And as I've said before, that kind of speaks to me, but back of the book probably has that as x squared on 4 plus, if I was to multiply this by 4 on 4, I get 4y squared on 9 equals 1. Okay. Now you'll see me lay this out a lot of times. To get an equation of an ellipse, there's really 5 things we need to know. We need to know h. We need to know K, and usually we get those together. We need to know A, we need to know B, and we need to know, is it opening, or is it wide, or is it tall? Those are the things we really need to know in order to create the equation. Sometimes we find out what C is, but C might be helpful in leading us to A and B, A and or B, but C's not part of the equation. It's just a hidden part. So when they give us the foci, if the foci are here, that means, I don't know how wide this ellipse is, but it means the ellipse wraps around there, and this would be our major axis. We don't have the major axis length until we read it up here, and I didn't draw this to scale with that. But when they give us the foci, here's what I know. I've got HK. HK is the distance, or is the midpoint of the foci, and that's 0, 0, although we already knew that in this problem. The other thing it gives us is you can't spell focus without C. The C value is 2. And it also tells us that we are a wide or an x-dominant ellipse. but I don't have A and B yet. Now, when they give us the major axis is 10, we're 5 to the right, 5 to the left, that gives us A. So here's what I know so far. We have an x dominant, so x squared on A squared, 25, plus y minus 0, y minus k, y minus 0 squared on B squared equals 1. I need B. I've got A, I've got C, and we've learned that A squared equals B squared plus C squared. It fits this right triangle. So A squared, 25, equals B squared plus C squared, 4. So B squared equals 21, and a lot of times I jokingly say, so what's the value of B? The answer is, who really cares in this problem? I want B squared to go here, 21. Now, if I was drawing it and trying to be accurate, first off, I'd move my 5s out further, but now I would know that from here I'd go up the square root of 21, somewhere around 4.5 or so, and down the square root of 21. Okay, so let's continue to lay this out this way. Love to know A, I'd love to know B, I'd love to know H, I'd love to know K. I think I did a different order. I'd love to know which direction is it opening. Is it right, left, or is it up, down? And maybe I'll know C along the way, but maybe I don't need it. So vertices, 8 and -8, and those are the vertices. And if they say vertices, they're talking about on the major axis, unless they say minor vertices. So if they just say vertices, this is the major axis. And what did we learn there? Did we learn A? Yes, if this is the major axis, this length is 8. The whole thing's 16, but A is 8. Did we learn B? Nope, I don't know how high it goes. I just know it goes up less than 8. Did we learn HK? Well, we knew HK to begin with, but if I didn't, it's just the midpoint of those 2 points. 0, 0. Do we know C? No. And then we know that it passes through the point 53, which I'm going to just estimate it right here. ... So what do we have so far? We have this is an x squared, x minus 0 squared on 8 squared, 64, plus y squared, y minus 0 squared on b squared, I don't know, equals 1. But we have a solution point that's not on an axis. And with that solution point, I can put that in and solve. It's not going to be the prettiest answer, but let's see what we get. 5 for x, I get 25 on 64, plus 3 for y, 3 squared, 9 on b squared, equals 1. And I need to solve this for b squared. And here is what I would do. I would get rid of fractions. I'd multiply everything by 64 b squared. When I distribute, the 64 cancels, I get 25 b squared. The b squared cancels, I get 9 times 64. And on the left side, nothing cancels, I get 64b squared. So subtract 25b squared, and I get 39b squared equals 9 times 64, or 576. So b squared equals 576 on 39. And I'm just going to math fraction that and be lazy. Let's go 576 divided by 39, enter math fraction, and we get 192 on 13. So now I've got x squared on 64 plus y squared on big old 192 on 13 equals 1. Multiply this by 13 on 13, and the 13's cancel in the denominator, and we end up with x squared on 64 plus 13y squared on 192 equals 1. And there we have it. Okay, now let's get some ellipses that do not have circle at the center. They give us the vertices, and you can try to do this without drawing a picture. I think it'll be tough. They give us the vertices. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my vertices, which means the ellipse is coming around like this. I want A, I want B, I want H, I want K. When they give us this is a length of 8, therefore A is 4. I don't know B, I don't know how wide it is yet. I'm going to very shortly. HK is just the midpoint. The middle value, the middle of 3 and 3 is 3. The middle of 1 and 9 is 1 plus 9, 10 divided by 2, 5. And we notice from that 5, that's up 4, down 4 to get to 9 and to get to 1. So our center point is 3, 5. I don't know B yet, but then they tell me the minor axis length is 3. So there, we'd be right over here. Right over there. And that gives us our shape of our ellipse, but it also gives us B. B is 3. So we are just about done. It's tall. Therefore, this is a y dominant. So I like putting the y first. Y minus k, y minus 5 squared. It goes on a squared. A is not married to x. It's the long, and this is tall. So the tall y gets the big value on 16 plus x minus 3 squared on b squared. B is 3. 9 equals 1. And there we have it. And you're going to see a number of different ways they try to convolute this, but we should be able to work our way around. So center 3, 2. And I'm going to argue that they didn't really need to give us that. Let's say they just gave us the foci at 1, 2, focus 1, and 3, 4, or 3, 2, 3, 4, 5, 2, focus 2. If they gave us those, I know that the curve wraps around the focus. This is on the major axis, and the curve's going to look something like that. Don't know how wide it's going to be. But I do know that the center is the midpoint of these. And the midpoint of 1 and 5 is 6 divided by 2, 3. And the midpoint of 2 and 2 is 2. So there's our center. I've learned that this is a wide one. I've learned that C, can't spell focus without C, is 2. So what do I know so far? This is going to be an x minus 3 squared on something plus y minus 2 squared on something. This is my a squared right here. This is my b squared, is going to go right there, equals 1. But right now, all I know is C. C is 2, but for whatever reason, they gave us this relation. And that could be because we know the eccentricity, which we'll talk about shortly. But that means that A equals 3 times 2, or 6. If A is 6, I'm 36, and I'd need to go over 6 from here if I was going to graph it. And I need to go left 6 from the center if I was going to graph it. And don't forget, there's a Pythagorean relationship between A, B, and C. A squared, 36, equals B squared plus C squared. C is 2, so plus 4. B squared is 32, and really that's all I need is 32. And we've got it. Okay. All right, good time to go back and talk about that eccentricity right now. So eccentricity is C over A. That is a measure of roundness. And we know that A is bigger than C. A is bigger than C. C could be bigger or short or smaller than B, but A is always the biggest. So if A is bigger than C, that means that 0 is less than E the eccentricity is less than 1. So one of those must be, well, it's really round. Like if the eccentricity was close to 0, it's either really round or really flat ellipse. And one of those and the other must be, well, if this is really round, that's really flat, vice versa. And there would be ways of understanding it after we go through actually drawing a picture of this mechanically. We'll do that in class. I won't do it on this video. But wow, what an easy way to remember. The closer the eccentricity is to 0, the more the ellipse looks like a 0, the rounder it is. And the closer it is to 1, the more it looks like a 1. Now note that 1 might be a flat 1 lying on its side, but the more it looks like a 1. So an eccentricity of 0.98 is going to be really skinny, either really, really short and flat or really tall, skinny. An eccentricity of 0.01 probably looks exactly like a circle, although it would not quite be a circle. In theory, if the eccentricity was 0, we would have a circle. If the eccentricity was 1, we would have a line segment. Okay. Let's wrap these up. Find the center, vertices, foci, and eccentricity of the ellipse. So let's just do this. Let's go H, K, A, B, C, and E. So HK, the most interesting value of x, -3, K, 2. So our center is at -3, 2. A is 4. So square root of 16, 4. This is a big one. So this is a tall. Let's see, was I supposed to graph some of these previous ones just to check? Nope, we're good. Okay. And here we're supposed to end up graphing. And then let's see, B is the square root of 12. That's the smaller value. So that is 4 times 3 or 2 square root of 3. Square root of 12. I'm just going to put it here. You'll see why. And C, well, A squared 16 equals B squared 12 plus C squared. So C squared equals 4. C equals 2. And E equals C over A, or 2 over 4, or 1/2, which means this is kind of a halfway in the middle between round and flat. Okay, and now we're supposed to graph it. So let's see, I need some room to the left, and I need some room up, left and up. To the right and up and down I need to go 4, and left and right I need to go less than 4. So that gives me an idea what I'm looking like here. -1, 2, 3, 2. There's our center. I need to, from there, go up and down 4. From here, down 4. So our ellipse looks like this. And I need to go right and left about the square root of 12, which is between 3 and 4, pretty close to the middle of 3 and 4, I would guess. So between 3 and 4, so 1, 2, 3, I better be a little bit over here. And 1, 2, 3, a little bit over here between those. Mine doesn't look like it's tall and skinny. I think my scaling's not the best. Mine really looks like it's shorter. But remember I said it was going to be kind of a midland here. So this one's really taller than it is wide. But we can see that by the scale. I'm just not square with the scale. So have we done everything we can? The vertices. These are the vertices. So how did I get there? I went left 3, up 2, and up 4 more. So the vertices are left 3, up 2, up 4 more, so up 6, and left 3, up 2, but down 4, gets me to down 2. How about the foci? To get to the foci, well, the foci are, I think I did this wrong. Nope, there's our B. To get to the foci, we go 2. I'm okay. I was thinking I got my foci and my C and B mixed up. To get to the foci, I go 2 toward the vertices, so that's up 2 from here, down 2 from there. So the foci are located to the left 3, up 2 and up another 2. To the left 3, up 2, back down 2, 0. Vertices, foci, eccentricity, and the eccentricity we already have. If they asked for the minor vertices, we would have those as well. That would be left 3, minor vertices. How do we get there? We go left 3, then we go another 2 root 3 to the left, and we are up 2. And to get to this one, we go left 3, and then back positive 2 root 3, and we're up 2. It's kind of a nice shortcut, but that's if they were asking for the minor vertices. Sorry. Here we go. I'm going to go through that again. How did I get here? I go left 3, up 2, but I'm an additional 2 square root of 3 that way, and an additional 2 square of 3 back that way. My apologies for having that out of off the screen. Okay, now we got to do the work ourselves here. So here we go. I'm going to group my x's, factor out of 9. Why? Because I have to complete the square. Group my y's, factor out of 4. And I'm going to subtract 37 to the other side and complete the square like we did with parabolas. Half of negative 6, negative 3 squared plus 9. Half of 10, 5 squared plus 25. What did I really just do? I really just added 81, and then I added 100. So let's see. I think we got a pretty good value here. Let's see. I've got on negative 37 plus 81 plus 100 is 144. I was hoping so. 144, and I get 9 times x minus 3 squared plus 4 times y plus 5 squared equals 144. Now, here's where some people get mixed up and they think, well, I don't want 9 and 4 divided by 36. But that's not the case. I'm now driven by this side. I want this side to equal 1. So I'm going to divide by 144. And I get x minus 3 squared on 9 divided by, or 144. This would be if I multiply top and bottom by 1/9. I get 144 divided by 9, which I think we all know. But we get 16 there on 16. Plus 4 on 144. If I multiply by 1/4 and by 1/4, I get y plus 5 squared on 36. So it took all that to get to that point. Now we still have to graph this thing. Okay, so my center is right 3, down 5. And from that point, I'm going to the right. So we're supposed to list that. Center is 3, negative 5. From there, this is a tall one. So I'm going to go to my vertices next, which requires me to go up 6, down 6. So up 5, up 6, down 1, 2, 3, 4, 5, 6. Where's that get me for my vertices? I was right 3, down 5, but up 6. So I'm right 3, up 1. I was right 3, down 5, down another 6, 3, negative 11. And the ellipse looks like this. Now, how wide should I go? 4. So I'm going to come over to here, and I get that minor vertex, and 1, 2, 3, 4 over here get that minor vertex, and I'm going to try to draw it flat out of here to flat into there. Comes flat out of here, flat into there. I might have that 0 missed. It wasn't the best. Flat out of here to there. So I might not have the y-intercepts right, but I have a pretty good shape there. Okay. Eccentricity, C on A. I need C. What do I know so far? I've got A is, I learned 6. B is 4. And I know that C squared plus B squared equals A squared, or C squared equals 36 minus B squared, 16. So I get C is square root of 20, or pull out a 4, 2 root 5. So square root of 20 is between 4 and 5. So I need to go up between 4 and 5, down between 4 and 5. And how did I get there? My foci, I went to the right 3, I went down 5, and then I went up and down square root of 20, or 2 root 5. Up or down to square root of 5. And finally, the eccentricity is C, 2 square root of 5 on A, 6, or square root of 5 on 3. There's just a whole lot of easy going on there. Okay, and 50. You'll get some practice on those. 50. Find an equation of an ellipse with the given characteristics. Well, I'm gonna sketch this. Vertices 0 plus or minus 8. What's that tell me already? Center at 0, 0. It tells me it's tall. It's a y squared. Y minus 0 squared. It gives me A. If those are the vertices, A is 8. So y squared on 64 plus an x squared on, I need B squared. But I know A is 8. And I know eccentricity equals C on A, or C on 8, and that is 1/2, which tells me that C is 4. Well, I don't care about C, I want to find B. Well, I've got A and I've got C. And A squared equals B squared plus C squared. So B squared by subtraction is 48. And there's our equation. Okay, the foci, not my favorite. They're giving us C right here, but they are going to give us the center. Let's take a look. My foci are at negative 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. And I've got another one at 2, 5. So where's our center? Not the C value. Our center is halfway between those. Halfway between negative 6 and 2 is the average of those. Negative 6 plus 2, negative 4 divided by 2. Halfway between 5 and 5 is 5. There's our center. If these are the foci, the ellipse looks like this, and this is an x dominant. So I've got x minus negative 2 squared on A squared. Come back to that. Plus y minus 5 squared on B squared. Now they give us eccentricity 4 on 5, and this is a load, and I've got just a little bit of time here. Hopefully I can finish this one, otherwise I'll have to have it to be continued on this. But eccentricity, here's what I know. I've got C on A equals 4 on 5. C on A are in ratio to 4 on 5, but I know C. Here's the center. Negative 2, 5. I've got C right here. C is the distance from 2, 5 over to negative 2, 5 over to 2, 5. So that is a distance of 4. We're 8 between these two. So C is 8. So I've got 8 is to A as 4 is to 5. Cross multiply, I get 4A equals 40. A is 10. 4A is 40. A is 10. So this becomes on 100. And now we know that A squared, 100, equals B squared plus C squared, 64. Oh, once again, I didn't show all that work. I apologize. You can take a look at that. We knew that C on A was 4/5 given, and we knew that C was 8, and that led us to A is 10. So x plus 2, this is y, is on 10 squared. And now I've got b squared equals 36 on 1. So there you have it. We'll definitely get some practice on these. I expect we'll have a number of questions. But that's a good reference for you, and you will, of course, let me know if there's anything I can help you with.